In a previous video, I explained how I use my ball mill to make aluminum powder for thermite. In this video, I will be showing my electrolytic rust generation setup, which is how I generate rust as the secondary component of thermite. So first, you're going to want to take a large container filled with water. This is 24 fluid ounces. And into that container, you'll want to add about half a tablespoon of salt and stir it around. The salt acts as an electrolyte, which lets the water conduct electricity. Normally, water doesn't conduct electricity very well, so this helps it conduct more, which increases the amperage allowable by the cell, and thus you get more rust faster. And so when the salt is all dissolved, then you'll want to take your iron source, which I'm using old railroad spikes. And these railroad spikes work really well because they're dense, they're easy to find, they're cheap, and they work really well as electrodes. I usually just stick one on one side and one approximately on the other like that. Now in this setup, they might fall in, which would be very detrimental to a kind of hands-free electrolyte setup. So I use these little spring clamps to clamp them on like this and that. And then the next thing you'll need is your power source. For that, I am using an unmodified computer power supply. Really anything that produces 12 volts will work, like a wall wart, a laptop power supply, or even a modified computer power supply changed to be a desktop kind of lab power supply. So here is the power supply, and if I just plug that in, then I'm using the ATX PSU power connector. It's this 4-pin one. It's got 2 black wires, 2 yellow wires, and I just plug in these, which are kind of just 2 little wires connected to 2 bigger wires. The big wires and the 2 little wires in parallel kind of distribute the amperage so that these don't get hot. I tried using normal alligator clips you might find in electronics kits, but they really don't work and they get very hot. In fact, a few of them completely burnt out. As you can see, the 2 wires are plugged in by the 2 smaller wires into the ATX PSU connector, and on the end they're just stripped. So what I'm going to do with this is use this as the positive. As you can see, it has the red tape, and I will connect it to the less worn railroad spike, which is this one. The positive gets eroded away, and the negative is kind of like electrolytically protected. And I have found that these railroad spikes are actually really hard to attach wires to. So I found that using small neodymium magnets to sandwich the wires onto the cleaned head, I sanded it a little bit, works really well to keep the wires connected and then also in contact with the good clean portion of the railroad spike. So I'll just hook those up, and then if we turn on the power, it's spinning but it's very quiet. You can see that there are lots of bubbles evolved on the negative terminal. The negative will be just the same weight as it is right now, and the positive will be slowly eroded away until your solution is very black and completely covered in sludge. It's been about 36 hours, and now as you can see, the electrolyte bath has turned a very dark brown, black, muddy color. And as you can see, I also used an ice cream bucket full of water to act as a sort of secondary containment and coolant system, because the electrolyte bath was getting very hot, and I don't really like to boil away a lot of water while I'm leaving it unattended. So the next step is to take everything out and then clean it off using a spray bottle to spray the rust back into the container. Okay, I got the railroad spikes and clamps cleaned up, and as you can see, the mix is a very dark, extremely thick sludge that can almost really support its own weight. So the next step is to clean off some of the water and make this a little bit drier so that it's more manageable when we bake it. For that purpose, I use t-shirts placed in these cheese containers. You can really just use any wide mouth container. And then I pour the mix into there and let it sit for about half an hour until at least some of the water drains out. It's been about half an hour, and now that the sludge is significantly more dry, the next step is to spread it on an old cookie sheet for baking in the oven. And I have this cookie sheet. As you can see, it's very rusty from use. And it goes without saying, do not use a good cookie sheet for this. If you do, your mother or your wife will kill you, and then you will not be able to make thermite, and that's not fun. So use an old cookie sheet and save yourself the trouble. Now I have the rust spread on a cookie sheet, and the oven is set to 400 degrees Fahrenheit. So I will put it in the oven and leave it there to bake until it is very crispy and a uniform red color. This can take anywhere from half an hour to an hour and a half. Now the rust is out of the oven, and it's mostly a kind of dark red color, and as you can see, if I crush up some of the chunks, it's a kind of different red, but that's great. So now I'm going to scrape it onto a piece of paper for transferring to a glass jar for the last step, which is ball milling to make it into a fine powder for thermite or rocket engines or whatever. As you can see, that's quite the pile of rust there. I think that'll do quite nicely for thermite. Okay, so I took it out of the ball mill after about half an hour, and I had to switch containers to this plastic peanut butter jar because the glass spaghetti jar broke. But this is the final yield. It kind of looks chunky, but in reality it's a super fine soft powder. It's very, very soft. And this should be really good for thermite. It'll provide a nice fast reaction rate, and it looks pretty homogeneous, no irregular clumps or anything. So I'm pretty happy with how it turned out.